we first want to find a polar representation of the complex number z. So let's start off with that instruction. So we got z is equal to 9 plus 9i. First off, this is represented by A, and this is represented by B. And if I just looked at the graph, A is our x value, so that's right here, and B is our y value, so that'd be right here. And this is going to have a angle here, and it'll also have a distance here. You can see that represented as r. That's referred to as your modulus of z. That's its distance. Okay, well, first off, and this is actually one of the things they're asking you to find, is the modulus of z, which is the same as r, is equal to the square root of a squared plus b squared. I'm just going to leave it as r here. So a we said was 9. So we got 9 squared plus, and b is 9, so 9 squared. So that's going to be 81 plus 81, which is 162. Now if I did the prime factorization of this, I'd have, what would I have? Let's see. 2 times 81, this is 3 times 27, 3 times 9, and 3 times 3. Okay, so we got 2 and then 4 3s. Now we're looking for pairs of something. Here's a pair of 3s, so that's going to come out in front as a single 3. Here's another pair of 3s, so they're going to come out in front as a single 3. So we got r is equal to 3 times 3 square root of 2, or r is equal to 9 square root of 2. So one of the things they're asking you to find is the modulus of z. It looks like the absolute value, but that's modulus when referring to working with numbers of this form. And that's 9 square root of 2. Okay. Now that's one thing we have to find. We have to find r. The other thing we have to do is find theta. Now, when you're doing this, there's two types that you can run across. One type that's on a unicircle and one type that's not on a unicircle. First thing we do is we try to see if it's on a unicircle. And how we do that is we plug them into our formulas. We got cosine theta is equal to x over r, and x is a, so a over r. And we got sine theta is equal to y over r, or b over r, in this, for these on this notation. Let me see. A is 9. R was 9 square root of 2. 9s would cancel, and I got 1 over square root of 2. Multiply top and bottom by square root of 2, and you get square root of 2 over 2. Now B is 9, and R is still 9 square root of 2. So this is going to give us the same idea. You multiply the top and bottom by square root of 2, and you get square root of 2 over 2. So we have square root of 2 over 2 and square root of 2 over 2. Now we're looking on our unicircle. So going around the unicircle, and we're looking for the point square root of 2 over 2 and square root of 2 over 2. This point right here is pi over 4, or if you want it in degrees, it'd be 45 degrees. And this point is square root of 2 over 2 and square root of 2 over 2. So we can see that our angle is going to be pi over 4. Now sometimes you'll find it easier to put it into degrees, especially when we're doing other formulas. So you should feel comfortable with it being either way. Okay. Now recall, we said, let's say r is equal to, okay, let's try it again. Theta is equal to pi over 4. There we go, that's better. So now we want to write down our polar representation, which is r, and then CIS theta. Well, r we said was 9 square root of 2. CIS, this refers to cosine and sine. The I is imaginary. And then our angle was pi over 4. Now some books you'll see it written that way. Some books you'll see it written as 9 square root of 2, and then you'll have cosine of pi over 4 plus I sine of pi over 4. So it varies. Some half books look at, I see it in this way, half of them are written in this way. Okay, so that's our polar representation. Now we also needed this RE of Z. Now this is our real part. And our real part is obviously the 9. Now this next part's our imaginary part, excluding the I. Well, the number that's in front of the I is a 9. So that'd be our imaginary part. And then they want the argument of Z. Now with this, you have this angle here, pi over 4. But if I start right here and I go all the way around the unit circle, add 2 pi, I'm back to where I started. And so there's an infinite number of representations of this. So we're going to say pi over 4 plus 2 pi k, where k, this is given k is an integer. Now we also have our principal argument, which is our beginning angle theta, which in this problem was pi over 4. And was there anything else they were wanting? I guess that's it.